Alrighty, here we're going to talk about significant figures. I hinted at this in our accuracy and precision video, but significant figures are going to be important, and I want us to be able to pay attention to this and know what we're dealing with this, because we're going to have to deal with significant figures throughout the entire course of Gen Chem 1 and Gen Chem 2. Significant figures are ways that we preserve the precision of our measurements in the data that we record and how we deal with calculations, okay? And when we're making physical measurements, it's easy to keep track of the significant figures because if we read the measurements correctly off of the instrumentation, we'll get the correct number of significant figures, okay? What we're going to talk about, though, is if you're looking at someone else's data or you're looking at a problem that we're going to be working, you have to be able to know what the significant figures are so that we can deal with it in a calculation. Okay, so the focus of this video is purely on counting significant figures and figuring out how many are there and what digits are significant and what digits are not significant. Okay, we'll work through some calculation and see the calculating rules in the next video. All right, essentially, all of our rules for significant figures deal with zeros. Zeros are jerks, right? Anything that's not a zero by default is a significant digit, okay? So if we look at this example here, the non-zero digits, they're significant. The other rules we have are dealing with the zeros, okay? So if your zero is between the non-zero digits, it's going to be significant. So this zero that's here is significant because it's stuck between a 5 and an 8, okay? Leading zeros are not significant. So these guys in the front, not significant. Not significant just means we're looking at placeholder zeros. Okay, so those zeros are telling us about the magnitude of the measurement, how small it is, right? Because there's, right, it's 10 to the minus 3. But they're not a part of the measurement itself, if that makes any sense whatsoever. Maybe, maybe not. We can talk about it. Terminal or trailing zeros, so zeros on the right side of the number, are significant if they are to the right of a decimal place. Okay, so that's the terminal zeros are what's going to throw us off. Here's our decimal place. This zero is to the right of it, so it is significant zero. Okay, so we would say the number that's here has 5 significant figures. 50830 is 5 significant figures. Okay, we're gonna have to clarify this terminal trailing zero business. So if they're to the right of a decimal place, they're going to be significant. Okay, that's like the example we just saw. If there's not a decimal point in our measurement, then it becomes ambiguous. And so we say they may or may not be significant, and it just depends on how you want to deal with it. Okay, so for example, let's think about the number 1200. Okay, depending on what you're doing, this number could be 2, 3, or 4 significant figures. Okay, depending on one or both of those zeros are significant. The 1 and the 2 are obviously going to be significant because they're not zeros. So there are ways to think through this. Okay, so this is, we don't know how many significant figures. We can give it a decimal point. Okay, that looks a little weird. We can give it a decimal point. This makes it 4 significant figures. Okay, you can give it a 0 after the decimal place. That's 5 significant figures. Okay, not too terrible. What if, and we're talking about this in the next video, how we figure this out, but what if we want it to have 3 significant figures? Okay, 3 significant figures is going to require us to have scientific notation. Okay, and that would mean 1.20 times 10 to the third. Okay, as we do that, when we're thinking about scientific notation, everything that's in this piece of the number is significant. Everything that's out here in the exponential part is placeholders and not significant. Okay, so if you want 3 significant figures, you have to have scientific notation. Of course, we could put the other versions into scientific notation. So that would be saying, well, we could have 2 oops, 1.2 times 10 to the third, or 1.200 times 10 to the third. This would be 2 significant figures, and this would be 4 significant figures. Okay. We can't really add this 0 here because it's not in our original piece of information. Okay, so 5 significant figures is kind of off the table there. Okay. Oh, I just did this piece. Scientific notation contains only significant figures. This is the stuff in the front part of that number. Okay. So things we need to be able to do at this point is, can we look at a number and figure out how many significant figures are there? Sorry. So let's say 6.03400. Okay. 6, 3, and 4 are significant. So the 0 in between is also significant. So far, all of these are significant. These are trailing zeros and to the right of the decimal place. So those are also significant. So this is 6 significant figures. Okay, I'll do a couple of these. 000900500. Okay, this has all the zeros in it. Okay. Let's see. So the 9 and the 5 are, the 0 in between is by default. The guys on the front are not significant. The guys on the end are. So this is 5 significant figures. Okay. Practice, practice, practice. We have to be able to do significant figures. Okay. If you need anything, let me know, and I'll see you in the next one when we talk about calculations and their calculation rules. Oh, here's examples. This is just telling you what's going on. Can you figure out how many significant figures are there? These are pretty much the same examples like we just did. I'll run through them real quick. Maybe pause and think about it for a second, work it out. Okay, so this is 4. Okay, this is 3 because the left zeros don't count. This is 1, 2, 3, 4, 5, 6. Again, left zeros don't count, but the right ones do. In scientific notation, all of these are significant. So that's 3 significant figures. This is ambiguous, but the way it is written, I would say this is 2 significant figures because there's not a decimal place there. Okay. If I wanted this to be 4 decimal places, 4 significant figures, I would have put a decimal place right there. Okay. But I didn't. So we're not. Erase that. Okay. I think this is the end now. If I have one more slide, I'm going to be surprised. All right. I'll see you later. There it is. It's the end.